Welcome back to Rising Tide, the Ocean Podcast. This is David Helvarg, and my co-host is Vicki Nichols-Goldstein.
Hello, everyone, and how is everyone?
Hopefully well. The loss of the Titan submersible in June, unfortunately, during a dive to the Titanic, made global headlines, and for the first time, a lot of people became aware of the submersible community that includes remote-operated, autonomous, and human-occupied deep-diving ocean vessels other than submarines. Today, we're pleased to be speaking with Tony Lawson, Engineering Director at DOER Marine, that builds both ROVs and submersibles. Tony has 24 years experience in the subsea industry and also has worked on marine robotics. He spent 15 years on the American Bureau of Shipping Safety Rules Committee for underwater vehicles. Also, he's overseen the engineering, building, and piloting of a number of these unique vessels. But Tony, before we get into the history of deep ocean exploration and the craft that take us down there, tell us how you first connected with the ocean and how or if that led you onto the career path you've chosen.
I was born and raised in Hawaii, and of course, initially interested in the ocean, interested in marine biology. So my father, who was a mechanical engineer, worked around the world on large mechanical engineering projects, power stations, things like that. So the two kind of combined for me in the end.
So where'd you go to school? Stayed near the beach?
Mechanical engineering graduate from UCSB, so Santa Barbara, California.
When was your first experience like going into the ocean, going under the ocean, just experiencing the ocean?
Can't remember. I was swimming before I could, while I learned how to walk. We lived literally one block from the beach, and I grew up. There's pictures of me as an infant crawling in the sand, crawling in the ocean. So I'm water baby. Yeah.
Gills and lungs. That's a good combination.
Yeah. Comfortable in the ocean.
And so you went to Santa Barbara, colder water, but you focused on what, mechanical engineering?
Mechanical engineering, and then towards my senior years, I took graduate classes in marine design, marine systems, things like that, because I was had elective space and got into some stuff that was pretty interesting and a little bit mathematically hairy, but still not sure where I was going to go in my career, but it turned out to be pretty applicable.
Where did you go with your career? What was this marine work that you began?
My dad being in the more engineering construction side, I actually went into marine contracting, companies that build, piers, pump stations, things like that initially. But I wasn't really doing mechanical design. It was more build and specification. So after a few years of that, I just realized it wasn't really what I wanted to do. And strangely enough, the company that I work for is almost a stone's throw from us here in Alameda now. And they're still going strong, and I still know those guys. And they do fascinating work. But I ended up shifting to kind of subsea design and robotics kind of coincidentally. My girlfriend at the time, her stepdad was the safety science dive officer for Scripps, a man named Jim Stewart, very well accomplished, first generation diver. Well, one of his buddies was Sylvia Earle, and her company was looking for engineers in an industry I didn't even know about, and kind of fell into it. And then it was like they were building some subs at the time, the Deep Rover 1002s, still in operation today, and was pretty much fascinated at that point with what was going on and what could be done as an engineer.
So fellow at the Scripps Institution of Oceanography introduced you to our friend Sylvia Earle, who had just started the first of her submersible companies, and you got onto your first project, which was what?
I mean, the 1002s were in progress. The Deep Rovers, they'd actually built a Deep Rover first generation before that. But, when projects like these, they're building a pair of subs, and they just suck up your engineering department. So they were short staff, and I was kind of brought in more as a support engineer, but I got sucked into the subs as well, worked on the manipulators on that. And then I ended up staying on afterwards, working on ROVs and learning the industry kind of from the ground up.
And again, for basics, a Deep Rover is a submersible. Maybe describe what it is, and does.
The Deep Rovers and the 1002s particularly were a pair of acrylic hulls. They use a full acrylic sphere as the pressure hull. They were designed for 1,000 meters, rated and classed submersibles. They could take two people, one designated pilot and then a passenger scientist as crew. They were commissioned by Canal Plus, a French company, to do filming and science exploration. They were doing a kind of a Jacques Cousteau style ocean exploration series with these pair of subs that they had commissioned. So the 1002s were beautiful build, a beautiful application of this acrylic sphere technology subs.
Tony, when we're talking about the mechanics of ROVs and submersibles, and I'd like to know how it was your first time, your experience of going underwater.
Well, I think one of the pictures I sent you was the first picture of me in a sub, first launch off of a pier. It was just a weight and balance check. Acrylic hulled subs are fascinating. They're very unique. The acrylic has a very similar index of refraction of water. So when they drop into the water, the outer skin of the acrylic disappears. There's a little bit of refraction at the inner surface, the air acrylic interface, but basically you're sitting suspended, a pair of chairs surrounded by the ocean. And it's an incredibly immersive experience. So far beyond what you get out of a camera telepresence from an ROV. I know Sylvia has spent her career trying to relate this. Why do we need manned submersible? And once you're in it and you see it, it hits you right away. There's just nothing like having the human eye and being in it and there and having it just, you can look and see and feel the ocean. You're in it. You're part of it.
And you worked on these mechanical arms. So because you can't just reach out with your hands, do you do a lot of work to give it something like a hand feel or a natural way to manipulate?
I wish we could. The cost of developing a truly tactile feedback input-output system for a manipulator would be phenomenal. There are systems out there that do give you those type of tactile feedbacks. But the truth of the matter is, particularly for science subs, that the money's not there for that type of development. It's already going to be consumed by just producing the submersible, operating the submersible, surface ship, surface support personnel, everything that's required. Subs are very expensive to operate. That is the downside. So the manips are at best kind of put in last and serve a purpose, but unfortunately don't satisfy that tactile feel. They are joystick driven, kind of bang, bang for each joint. You move it, position it, move it, position it. It's a slow, methodical process to pick something up or do a coring or do something like that. And it is not tactily satisfying, but it is scientifically productive. So it does meet the end.
So as a mechanical engineer, you certainly learned about how to build these, but what about the skills or training necessary to pilot an ROV? Are there standards, or do you just get in there and learn from experience?
There was an operational standard. So the 70s, step back, the 70s were the heyday of manned submersible operations, funded primarily by the petrochemical industry. They were doing a lot of manned submersible operations to support the wellheads, things like that. They have since moved away from that to ROVs because of the cost and the liability of manned operations. During that time, a lot of operational procedures were developed. And there's a set of books we have, the MTS keeps them published. They're called the Red Book, the Green Book, the Yellow Book. And they cover the operational procedures, emergency procedures, what you do under certain situations, how you should operate. And those rules have been folded into what we hear of as the classing rules these days that will review your operational plan before you're classed to make sure you're following some of the basic standards that were established through years of man-hour experience and dedication, and then almost a perfect track record from the 70s. We've had no incidents, deaths, anything in the class submersible industry. But those rules have been well established. There was a big symposium. Pritzlaff was the author that generated a lot of the operational parameters. And then we ourselves, Ian Griffith, our head of operations here, has trained literally hundreds of scientists to be sub operators, because there are some subs out there that are single man, and you have no choice but to train. You can't train a pilot to become a marine biologist PhD. So you have to take the marine biologist PhD and train them to be a sub pilot. And they can be difficult and unruly. And even Sylvia is known to kind of, Sylvia, it's time to come up. Sylvia, time to come up. Because they are in their element and they are loving it.
And you've worked on both ROVs and you actually have several submersibles that you've taken from thought to water. What's that process like?
Long and somewhat expensive. It's very detailed work. The ocean's very unforgiving. So you spend a lot of time counting bolts and counting weight and balancing things and making sure things are going to operate. Some of it's, years of experience. Some of it is a little bit of everyone looking at how they do this, how they do that. These projects are years long, generally, at least a year to develop a decent ROV. Even reproducing one that's already been made once takes a fair amount of time and evolution just to see what to roll the best revs back into a product or something like that. Submersibles are, a year and a half to 2 years if you want to develop a new submersible of, an engineering team working full time.
There's conversations about pushing the envelope, trying to come up with some new design. Tell us a little bit more about that, because we've been hearing in the news, stick with what we know. We have pressures, we have materials, we have a general understanding. So how do you push the limits to try and explore new ROV designs and submersibles, with also keeping in mind significant challenges and maintaining a very strong emphasis on safety?
It's doable. It generally takes what everything takes. It takes money. And I think the industry takes a bit of exception to what's being said that the industry is stagnant. We're not stagnant. Lithium batteries are allowed in class vehicles. Lithium technology is not that old. And there was a phenomenal disaster with the Navy ASDS. The SEAL delivery system burned. Their lithium batteries burned quite tragically and destroyed a near $1 billion program when they did. We still allow and have made allowance for the technology of lithium batteries to be incorporated in manned submersibles and class systems. We have a few safety factors that we've added into them. One of them being you must be able to jettison the battery pods. One of them decides to catch on fire, and water does not put out lithium fire. Well, let's just close a contactor, make that battery system jettison and go away. So there are ways to advance and bring good technologies, new technologies into this industry. And a lot of the discussion has been talking about, we got to break things to advance the technology, and things haven't been broken in this industry for a long time. And actually, that's not true. A man named Jerry Stash, who spent his entire career funded by the Navy breaking acrylic. He has volumes of work. The wrecks of what he has broken are still down at Port Hueneme, down in Southern California at the Naval Research Facility there, where there's these big concrete balls, because he discovered that concrete models almost the same. It's a plastic. It models almost the same as acrylic. And he spent tens of years busting balls, busting acrylic, qualifying acrylic. Sorry about that phrase.
And just to be clear, in designing and testing, you literally break things. You take them beyond their designated tolerance.
Absolutely. Yes. You find their limits and go beyond them. Basically, they've been there. They've done that. What was happening just recently, that wasn't doing anything new. And to then take paying passengers down, it's stunning to me.
So you have classes, which are literally organizations dedicated to safety. And yet with the Titan, clearly it wasn't classed. The guy in charge ignored standards. So is there a way to impose standards in the future so that people don't take an experimental craft and load it with paying customers and put them in harm's way?
Unfortunately, as far as I understand it right now, no. It's a little different than the aviation industry, which is globally synchronized. You can have an experimental aircraft, but there are limits to what you can do anywhere in the world with an experimental aircraft. With submersibles and the rules of the high seas, which are kind of sacrosanct, people don't want to impose international law on high seas. Once you're outside of the territorial waters of a sovereign nation, people like to kind of say that's, the last free frontier. And there is no one who can come along and say, no, you can't take your quote unquote experimental sub and dive it. There really are no rules to say that you can't take paying passengers out in the high seas and dive it. It's why the industry was so upset with the program, because they realized that this was treading on very thin ice, and that what happened would reflect on the entire industry if people didn't really understand the difference. And again, generally, if someone wants to go out and do that on their own, good luck. Have at it. Congratulations. But when you start taking paying lay people who don't really understand the science or the risk, you've crossed into a whole nother territory.
Tony, you have been in this field for decades. And I wanted to ask you how this whole tragedy really affected you personally, how you felt about it, and then how it really is impacting the profession.
I think it's a big question because there's multiple layers of how this played out. We knew this was going on. Stockton Rush came to almost everyone in the industry. It came through here. We were, always been class advocates. He was very much poo-pooing it. We've been waiting for this to happen. The industry has been waiting for this. Unfortunately, we kind of put it out of mind, like all of us did, from Cameron to Triton Submersibles, Leahy, and those guys. Everyone feared it. We feared the impact it'll have on our industry, if it'll kill the industry, if it'll cause overregulation of the industry. For me personally, my daughter, 15, she was at a hockey camp in the middle of rural Minnesota when this all went down. The entire camp was glued to the news, a bunch of 15-year-old girls. And when I went to go pick her up that following weekend, they had questions and they had fears. They were laying at night in bed wondering what it would be like to be trapped in a submersible at the bottom of the ocean. I was very surprised and a little shocked and definitely affected by how personal it had become for them. They were concerned about that 19-year-old boy because that was very close to their age. Did he even want to be there? And then I realized that, a lot of people were involved in this and that it was affecting them personally. So generally, we don't do the engineering operations side of this company. Doesn't do a whole lot of public outreach. Doesn't do a lot of video interviews. I realized people need to know. People need to understand what happened. How it's affecting the industry, I've seen a lot of experts or people saying, maybe the submersible industry needs a little more regulation. We've been regulating ourselves perfectly for 50 years. And fortunately, the classing agency responses haven't been, we've got to clamp down now. It's been, no, we've been doing it right. And I don't know if there's any way we can ever control what happened, as I discussed earlier. The high seas, you can't control them right now. And I don't see that ever changing. It's not going to change because of this incident, because there's far larger commercial implications with regulation of the high seas than something like this would ever warrant changes. And fortunately, the reaction from clients and funding has been incredibly good, because the realization, what I've really appreciated in the press, is that the discussion has been about class versus unclass, experimental versus non-experimental. And it has brought a realization that the majority of the industry is doing this very carefully and very, stringently. And we have a good safety record. And the clients we have, I think, are very appreciative of the fact that we've always said these will be class subs that we build, and your submersibles will be classed, and you will operate according to class rules, and you will be safe because of that.
Tell us just a little more about classing. What's a class in terms of the maritime industry?
So there are a set of rules, 3 or 4 different agencies out there. The big names are the American Bureau of Shipping, ABS, that's our underwater vehicle system rules. DNV recently purchased Germanischer Lloyd's, and they have a set of rules, GL. And then there is the British Lloyd's Registry, and they have their sets of rules. Rules dictate design, what standards you can use for design that include strengths, safety factors, how to build the hulls if they're steel, how to build the hulls if they're acrylic. The acrylic side generally defers to the ASME rules and then the PVHO rules, which means pressure vessels for human occupancy. And within those rules, there's the acrylic subsection, all of that established by the man Jerry Stashew years ago. The classing committees, so they have all these rules that kind of regulate how you build, how thick you make the hull, what materials you can use. And then they actually oversee the testing of materials, the qualification of the materials, physically taking coupons of the materials you're using for your pressure hull, testing them, testing their strength, watching or overseeing the pouring of the acrylic, the annealing of the acrylic, the machining of the acrylic, the assembly of the systems. They'll come and witness critical assemblies, cleaning of the oxygen systems, pressurization of the physical plumbing of systems to make sure that they hold pressure and can hold overpressure without fracture. They take a look at your operational plan to make sure it's considered safe in accordance to rules. They're in everything, and everything is submitted to them. They review it. They come back that it's been reviewed. They have a surveyor come to our facility and look over the materials, look over the assembly, check the machine prints of the part to the part that's actually made to make sure they conform, and then take note of that so that all goes in a permanent file for the vessel. It is a pretty rigorous process. It definitely increases the amount of time and work on the submersible by a factor of 2 at least.
So you've mentioned that major clients for ROVs and submersibles have been the offshore oil and gas industry historically. The ocean's in trouble. There's a lot of research going on, but a lot of the clients today seem to be either well-to-do tourists or billionaires who want to add a submarine to their helicopter pad on their yachts. As you say, it takes a lot of money to build a submersible. Where else are submersibles going other than entertainment value?
That's a good question. It's and we've seen the pivot since I got into the industry, where science and NSF were the primary funders, and then it is now switched to kind of broadcasting and entertainment production, and then it went to the wealthy individuals. At least at the time, there are enough wealthy individuals who care about the planet and are willing to not just make a toy for their personal use, but to really finance research and research capable vessels, or doing a hybrid kind of we'll use it for a little bit of tourism, but we'll also be doing science with it, kind of programs, which for the future seems to be where things are going to be going in this world right now. It's with the way the wealth is being distributed. That's where we're working, and we are certainly, our clients have switched to that. That is who we are working with now. Oh, and with Sylvia being who Sylvia is, the people that come to us generally are very much science interested, science proponents, and are bringing their wealth back to do some good.
So millions and tens of millions of dollars for submersibles.
Tens of millions very quickly.
And ROVs, remote operated vehicles, are a lot cheaper. So some people argue, let's just use robots and autonomous robots, and we can send fleets out into the ocean and learn everything we need to learn. What do you think of that?
Mine and our philosophy kind of growing together at this company, the right tool for the right job. AUVs are phenomenal for doing the tasks that require repetitive tracking, repetitive tasks, doing scans of the seafloor, back and forth, back and forth, back and forth.
Mowing the lawn.
Phenomenal at that. Mowing the lawn. And so AUVs are used for that. An AUV goes out and gets a hit, gets a target on something. Maybe it's a seamount, maybe it's a wreck. Putting down an ROV is a great way to go down and take a look. What is it? First, identify it, and then figure out, do you want to study it? Can we take samples from it? So ROVs are fantastic for that. And yes, a cheaper alternative. It requires fewer people. They're much lighter. They don't need as big a handling system, support vessels, etc. But the manned submersible offers an experience and offers the visibility that you just don't get from an ROV. You have that immersive experience that is incredibly human. Bob Ballard, when they discovered the Titanic, one of the first things he did was hop in the submersible, even though he's very much an ROV advocate, because there's just nothing like it. It really does. You see things that an ROV will miss. You'll be right next to it, and you won't see it, but the human eye will.
What's your favorite vessel to pilot?
We actually have in contract, we have a pair of 1,200 meter full acrylic hulled subs that we're working on. They're kind of that new evolution, basically, of the 1002s that I started working on almost 30 years ago. So I am looking forward to that. Things have evolved a little bit, better power. The battery pods are going to be smaller, so they're not generally on the 1002s. The battery pods set down below, and they block a lot of your down-looking view. With lithium batteries, we've got them fairly small, tucked in tight, so your view of bottom is going to be much, much better. So I'm looking forward to that, because really practically below 1,200 meters, there's not a lot to be seen. There is science to be done all throughout the depths of the ocean, but the acrylic hulls really, they're marvelous things in that first 300 meters. And I'm looking forward to building these subs and getting them operational. There's probably going to be a couple of years before they're done in the water, and they are kind of Sylvia's legacy. And I'm just looking forward to getting those in the water.
You're happy to putter along at 3,500 feet down. And I think given the overall safety record of the industry, I think Vicki and I would be happy to be ride-alongs.
Yeah, it's these subs are incredibly safe. They'll blow your mind. They're phenomenal.
I really like how you're saying these subs are incredibly safe. So for people who have been just like startled about this disaster. The message is there are safe subs out there. Do your homework. Make sure they're certified before you pay your money. And when you get in there, enjoy the beauty of the ocean.
Absolutely.
Great. Well, with that, we want to thank you so much for taking the time to be on the Rising Tide Ocean podcast. And we're excited about the future of ROVs and safe subs. And thank you so much for all the work that you do. To the ocean.
It's a pleasure. Thank you both.
Rising Tide is a production of Blue Frontier, co-hosted by David Helvarg and myself, Vicki Nichols-Goldstein, with support from Natasha Benjamin and Ellie Kurla. Rising Tide's editing services and technical support is provided by Studio Cape May. The theme song is written and performed by Ethan Kenvarg. You can find Rising Tide, the Ocean Podcast, at bluefront.org or download it from Apple, Google, Spotify, or wherever you get your favorite podcasts.
Off in the salty ocean, off where the waves roll free, the sparkling water rises, then crashes to the sea. Out amongst the breakers, you'll have no need to fear. It's true, it's the blue frontier. Off in the salty ocean, off to the blue frontier.
Sparky, come here, buddy. Sparky! There you are. Good boy, Sparky.